Our project is Levitating Balloons. My name is Harman Singh.
I'm Caden Dennis.
And I'm Casey Borowski. In this lab, we set out to determine the charges of two separate balloons. In order to do this, we measured the distance of the resulting interaction between the electrical forces and then plugged this distance into the force equation to calculate the charges. We assumed that the charges of each balloon were the same because we used the exact same induction procedure for each balloon.
The models for this experiment include a system schema and force diagrams. The system schema is made up of the balloons, a rope, a meter stick, and the earth. The force of gravity acts on everything in the model, shown by the green lines. The contact force of the rope on the balloons and meter stick is shown by the blue lines, and the repulsive force experienced by the balloons is shown in the red. The only thing being measured in our experiment have to do with the balloons. Because of this, they are the only things in the system. Our force diagrams show the forces that are applied onto the two balloons after their propulsion. Each balloon has an equal gravitational force being applied downward from the earth. The contact tension force being applied by the rope is equal and at a 70-degree angle on each side. The electrical repulsion force applied by each balloon onto the other are equal and opposite, giving us an 11-centimeter gap. To collect the data needed for the calculations, two balloons were blown up to a weight of 3 grams, then attached to a rope. Both balloons were then rubbed onto the arms of the same person for 1 minute to obtain a charge. The balloons were then hung over a meter stick and dropped. Once the balloons made contact, the repulsive forces were measured by getting the angles of the rope after repulsion and the distance between the balloons. A difficult challenge when doing this was getting the exact distance and angles measured due to the quickness of the process.
In order to do our calculations, we recorded the acceleration of the two balloons. We got the acceleration to be 0 meters per second squared because there was a repulsion force acting, and then the force tension was counter-interacting with it as well, so both balloons just levitated in the air. Mass recorded for both balloons was 3.0 grams. We then calculated the F net in the y direction, and that was to give us force tension, which we got 38.03 newtons. We then used this force tension to plug it into our F net in the x direction in order to determine the charges of both balloons. We then got that to be 5.69 times 10 to the negative 6 coulombs. And in order to solve for a number of electrons, we divide the charge by the charge of a single electron, which we used the internet to find, which was 1.602 times 10 to the negative 19 coulombs. The total number of electrons that were transferred was 7.10 times 10 to the 13 electrons. The limitations and assumptions that we had in our lab were that, first of all, it was really extremely hard to calculate and measure the distances and angles because both balloons were constantly spinning around when we were doing our lab, and the possible error in our data could have been because of our mass when we recorded it. One of the balloons' mass was around 2.967 while the other was 3.02, so we just assumed that both masses would be just 3.0 and we rounded. We were unable to determine whether the charges for both were either both positive or both negative. We know that they were both the same charge because of repulsion, but we're not able to really calculate that. And we assumed also that Q1 and Q2 were equal in magnitude. This is very difficult to determine without proper scientific tools.
From this lab, we concluded that although it is impossible to determine whether a charge is positive or negative, it is possible to determine the magnitude of a charge after which a charge is induced. We concluded that the charge on each of the balloons was 5.69 times 10 to the negative 6 coulombs. The charges were identical on each balloon, meaning that Q1 and Q2 were the same. Thus, we were also able to calculate the total number of electrons transferred, which was 7.10 times 10 to the 13th electrons. For the most part, we believe our model is accurate. We know that the charges will repel because the charges are in the same direction, meaning that they're either both positive or both negative, although we do not know for certain. Calculating the distance that was produced via the repulsive force was a difficulty because of the speed at which the interaction occurred. This is the only possible error that can stem from our experiment, thus arising the lack of reproducibility in the experiment. That is all. Thank you.